specifically about vibration analysis for the next 2 days. And what we're going to try to do is not give you the 2 or 3 weeks of technician training, but try to estimate what the engineer wants to know. So if at any point I'm not giving you enough detail, please holler and I will get more specific and mislead you in more specific ways. But you know, there are a lot of little technologies, and 3 main technologies that make up what's called predictive maintenance, or reliability engineering, or continuous monitoring, constant monitoring, or condition monitoring. Of the 3 main technologies that we've been using for years is oil analysis, thermography, and vibration analysis. Thermography is basically good for roofs, panels, and to the motor. You start getting on dangerous ground when you get into the looking at individual bearings. Now you're talking about the size of the bearing housing. Case in point, we were doing some training for the city of Lubbock, and we had a high frequency vibration coming from a bearing. We told the customer we would rather see you grease that. We'd like to see you grease that bearing. One of the supervisors took out his infrared gun and said the bearings are the same temperature. The outside housing was within 10 degrees of each other, but it was one of those real big housings that's made to transfer heat. And 3 months later, the bearing failed due to lack of lubrication. If he had waited another month, he probably would have seen a heat increase. At the time, when it was minor, where the bearings were just starting to skid, he couldn't see that with a gun, and he chose not to grease. So I feel that thermography really works best in most cases, just as a generalization, through the motor. Oil analysis is the best tool, I think, for most gearboxes, although we do a lot of vibration analysis on gearboxes. But anything like that, oil analysis should be your primary tool. And the thing about vibration analysis, you can take it a lot and get a lot of good information. Why do we want to use predictive maintenance? And I don't mean to not count the uses of things like ultrasonic technology, both for thickness testing and corrosion, and for especially for catching leaks. Although I find in the factory environment it's very frustrating. You need a very high skill factor to use ultrasonic consistently to find bearing faults, noise, and things like that. Anyway, functional programming. We should reduce maintenance and repair costs by 20%. Any good system can do this. Combination of these 3 programs, easy. Maintenance over time should be significantly reduced. I would argue that it should become a thing of the past. Equipment downtime will drop, and this is where your biggest payback is. If you can increase your equipment uptime by 10 to 20%, that's effectively free money. Right now, you're making X so much product per year. If at less manpower, you can increase 10 to 20%. You're talking a significant improvement to the bottom line. Vibration analysis should contribute at least 1/3 of these savings. In my experiences, usually thermography, most companies do thermography twice a year. Oil analysis almost on a when needed, but rarely on a on-demand, on a schedule. That vibration analysis very often takes over the lion's share of the cost savings. When you have a drive problem, you'll do a thermographic survey. When you have an oil problem, you'll do oil analysis. But already the vibration analysis is driving the rest of the program. The Central Soya facility in Indianapolis that blew up and was on the news about 13, 14 years ago. A few years before that, they started their predictive maintenance program in, I think it was '89. Within a year, we had a meeting and they had eliminated all overtime for their M&R department. And that's like 20, 30 mechanics. And they had one retirement that they didn't feel they needed to replace. Just another anecdote. Franklin International, the glue manufacturer down in South Columbus. We started a small program with them. One of the project engineers told me we only have enough maintenance time for you to do a small program because we can't fix any more than this limited program. 3 months later, he called me up and he said, we need to increase the program significantly. We have a lot more time for our manpower. Within a year, they had cut maintenance costs down so low, they decided they could do without one more engineer, and George lost his job. And the plant engineer took over predictive, as our contact for the predictive maintenance program.